Okay, I think it works well. Good, good. Now we have 20 people in the room, so I will just start. Yes. So today's content will be displayed into 3 sections. The first section is something before the discussion. And second, I will go through some confusing concepts. After that, I will give you some exercises, which will be helpful for your homework, for your lab, and for the exams. And this, okay, we have 4 sections. Sorry, the last session is some introduction to the coding with Python. And if we have time, probably MATLAB. I will also give you the links for the MATLAB license. Okay. So every section will not be very heavy. I will try my best to make everyone follow. Don't stress. And thank you for coming so early. It's early for me. I don't know if it is for you. All right. So before the discussion, I want to share that this class is really hard, not only in terms of a UCLA class, but also because it contradicts with humans' intuition. Since we were born, we get used to processing information in time domain, and we are familiar with that. But now we are told to understand, to explain, and to process information in frequency domain. So that contradicts with our habits, and it is so normal and also hard for me to get familiar with it. So I'm trying to say first, we should try our best to get comfortable with it. But at the beginning, it will be difficult, and the answer is yes. And don't feel that, oh, I'm so stupid. No, it's not. And the second one is because it is hard for your brain to learn how to get used to it. So just feel free to ask questions, even if your description is not that perfect. Just feel free to ask questions with no stress. Okay. And in the discussions afterwards, also feel comfortable to unmute yourself. I cannot see your face. I cannot locate you on Discord because everyone's name is a nickname, so no stress. All right. And regarding to the coding part, the Python and MATLAB included in this class will not be that hard. For myself, during my research, I use Python, I use C# mostly, and I have never learned it from scratch. I mean, I have not covered all of the topics under the language. So for myself, whenever I need to use it, I will Google it and learn it right away. So I mean, it is normal for you to forget some functions, to forget some syntax. But as long as you know how to search for them, how to use them, and then get more and more familiar with them, it is okay. So you don't need to memorize every details about your code. Our goal is to use them. Okay, so no stress about it. Mm-hmm. That is what I want to say before the discussion. Let's mark this is done. Now let's focus on the second part, the confusing concept. Hopefully in the following discussion, I will also add confusing concept section if necessary. I would like to hear some yes, got it, or I don't know, meaningless sound, because myself speaking is so lonely. Okay, confusing concepts. So first, it's about the convention. In the class, you'll see a lot of symbols, a lot of equations, and sometimes the convention is confusing. Here, I just want to talk about the most common one, x something, xn or xk. I will say that this symbol can be used so flexibly. when we write it in this way, Sn equals to blah, 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 and some signal. In this case, obviously, Xn is a sequence, right? A discrete sequence that you can read. For example, this is n equals to 0. You can read its values at different indexes, right? But sometimes Xn only represents one element among the sequence. For example, when we write down the equation, the shifting equation, like this, in the sum here, the xk only means the kth value in the brackets. Does it make sense? So strictly, we should notate that like this is an xn sequence, this is an xk value, but for simplicity, we just ignore them and just use the xn to describe. So it is confusing at the beginning, but as long as you get familiar with it, you understand what it represents in that context, you'll be good. Okay. So this is a first point in confusing concepts. And the second one, is called fundamental period. So the title sounds big. What is fundamental? But basically, it just means the smallest period. So you should find the n that satisfying this condition, but the value is smallest n. And we usually write it as np, if I remember it correctly. It doesn't matter what the notation is, but make sure you understand it. And then the next point is the unit step function. The unit step starts from n equals to 0 instead of 1, which means that this is 0. And some people will make mistake that, oh, it probably starts at 1, and it gives you a lot of trouble if you want to represent something in terms of unit step function. Okay. Someone talking out of the door. Okay. And I have this concern, but when I learned this class, I always mistake this delay and advanced their sign. So when you want to delay a function, delay a sequence, we use a minus, and for advanced we use plus. Okay, and I have myself memorize this by saying that, oh, delay is a bad thing. We don't want to procrastinate, so it contributes to a negative side. And I hope this helps you. And we are almost finished the list of confusing concepts. Just another two. So the second one is variable notation. Understanding this will help you in problem 5 in homework 1. So let's say we have an equation which sums from minus infinity to positive infinity. Okay, to make it simpler, let's not say infinity. We just say from 0 to 100. Okay. And then write another one. Are they the same, guys?
Yeah, they should be the same.
Thank you, Alexandra. Yes, they should be the same. So no matter what symbol, what notation letter you choose, it should be the same. And now, if I say m equals to minus k, and I want to represent represented with k. It ought to be negative k from 0 to 100, x minus k, y minus k, right? And if we remove the negative side here, it should be k from the minus 100 to 0 for x minus k, y of minus k. Does it make sense? Oh, we have 26 people, 24. Does it make sense to you? I see a thumb up from Sandra. Thank you. Yes. So now we replace a 0 to 100 with minus infinity to positive infinity. Okay. Now, what should be the range of k?
Is it still negative infinity to positive infinity?
Yes, you're right. You're right. Thank you. And let's suppose we have odd sequence, even sequence, which means that it is symmetrical. Assume we know this. Now what can we do? We can derive this, right? Because n or k, that means the same. Xk equals to x of minus k, right? And then we can rewrite this. So x, it is the same as xk and y minus k, right? And then suppose we know y is odd, which means that y equals to negative y of minus n. Of course, the same for k. What can we further transform this equation? Minus y of k, right? Does it make sense? Make sense to you all? Good. I thought thumb up. So thumb ups for you. Okay. So we can, if we take the minus out of the sum, we'll have this. And let's observe this with our original equation. What can we find here? This one use n. This one use k, right? So someone asked, why did you change from n to k? From n to k? Oh, good. So it follows my assumption that m or n equals to minus k. So I defined this, and then I make the conversion. I define I define n equals to minus k because I want to use the characteristics of even and odd. Exactly. Thanks, Edward. So if we forget about the minus sign, and we can see that this is a sum in terms of k. And if I change to from k to n now, oh, sorry. These two, one and two, are the same, right? Do you agree with me? Yeah. So previously, I let n equals to minus k because I want to produce an x of minus k, and then use even and odd characteristics. But after I simplify it further, I can replace a k with any notation I want, with any letter I want. And now I choose to use n again, and so this is a flexibility of the notation ladder. You can see, and then we compare 2 with our equation 0. We can see that it is in the form that something is equal to minus something. What does it mean? It means something is equal to 0, right? So the inference here is an even sequence times an odd sequence, and then we sum all of them, we will get 0, and this will help you in problem 5. And then you will write down the process yourself, which will help you strengthen the understanding. All right. So it is a bit heavy, but now let's come to the last point in the confusing concepts, which is very interesting. The professor talked about transformation a lot. And it is true that in this class, we aim to transform this time domain signals into frequency domain signals. And the intuition, why are we doing this? The intuition is, it will help us analyze the information more effectively, right? And I just want to give you a sense in the general picture. So suppose there is a track, there are some tracks, and then you are standing by the tracks and see your friends running in the tracks. So they're running from the start point to the end point, and they're running very fast. So sometimes, probably, it will be hard to see clearly about their motions, right? Because sometimes they will overlap and they'll go back and forth, and you can't distinguish it really well. And then you buy a plane, you buy a helicopter, so you can fly in the sky and then see from the top to the bottom, and you see the tracks look much more clear now, and your friends are in different track, right? So now it becomes clean, and you can see everyone clearly. Okay, so taking this analog back to our topic, we want to transform into frequency domain. It is hard to process, and when the frequency domain makes more sense. So for signal processing, this happens a lot. That is why we want to change our perspective and to process the information in another domain. Okay, someone asked a question. How do we convert back to n in the last step of the previous example? I think n equals to minus k, but it seems we replace with n equals to n equals to k. Good question. So that is why the notation sometimes is very confusing. We actually apply a trick here. So let's say from this step to this step, we replace n with minus k, right? But the k does not mean it has to be k. We can replace it by anything else, like n equals to minus t. Not t. T means time. Minus what? Minus a. N equals to minus b, or anything. Because the letter just represents the index, right? You can use any letter to do that. And in the last step, Actually, we can also replace it with other letters. Like we can use N, we can use P, we can use Q, whatever you use. So if we split it up, we will see that it is equal to, I mean, split the sum, split up the sum. The sum means some components adding together, right? Let's not consider the infinity. Let's say if the sum is from 0 to 2. So we have three components, 0, 1, and 2, right? So it should be like x of 1, x of 0, y of 0, plus x of 1, y 1, plus x of 2, y 2, right? And you see that when you expand the sum, the letter just doesn't matter because it just represents it is 0 or 1 or 2 in each component, right? So as long as your letter match the notation in the sum, it doesn't matter. Does it make sense? That is why I can use n to replace k again, because the k and n, they are basically the same thing. And I chose n because it will form a better contrast with 0, and then you can derive a equals to 0 here. Oh. So you should be proud of you if you write down this process, if you play with the flexibility with notation. So that is all about the confusing concepts. I plan to head for the exercise part. Anyone have questions before that? Woohoo. It seems we are okay. If you're not okay, you can also send me a message on Discord, okay? Exercises. I prepare 4 questions for you in exercise, and I think you can master each of this after some thinking. Okay, let's come to question 1. So suppose we have an equation in time domain, and we want to sample it into to be a. Oh, sorry. They are both in time domain. Now we have a continuous x of t, and then we want to turn it into a discrete sequence. Okay, this is our goal. Thanks to Hora. She's a previous TA, and she provided us references for the discussions. Thanks to her. Okay, let's continue. And suppose we have sampling frequency as high as 1440 hertz. Let's say, what is xn? And what is the period of xn? Feel free to unmute yourself and yell your answer. Xn. You can see that sometimes people are so lazy for the continuous time signal and discrete time signal. They use the same symbol. They still use S of something. So again, I can emphasize more. Should be you're dealing with. This is actually continuous time signal, and this is actually discrete time signal. But people just ignore, just use the same symbol for them. Get familiar with that? Okay, so anyone willing to give me the answer for xn? Or so this is defined to be the x continuous of NTS, which is covered in the lecture, right? So to make you stronger, I will remove the C here. Let's still use X as of NTS. What is TS? What is the relationship between TS and FS?
It's TS 1 over FS.
Great, great answer. So let's write it in terms of Fs. Yes. And then let's substitute n over Fs into the original equation. It should replace the position of t, right? So it should be 480 pi times n over Fs. Let's use the number. Fs is this, right? And 3 sine 720 pi n over 1440. Right. And let's save you from calculation. So this equals to 1/3 pi n plus. All right. So now we get xn, right? This is the answer to what is xn. What about the period? If you remember, for continuous time signal, period is t, the time, right? But for the discrete time signal, the period is an integer. It is a number. So let me give you the equations you need. For the discrete time signal, n equals to, f equals to omega over 2 pi, right? Which means that omega equals to 2 pi f. And then it is equal to k over n. And this is derived by, if we want it to be periodic, we should have 2 pi f n equals to 2k pi, which derived f equals to k over n. This is covered in lectures, so you can check about the more detailed version. Since we have this equation, we will be good. So for the first component, the omega here equals to pi over 3, right? Oh, someone give me an answer, and that is correct in almost correct. So this is 2 pi f, and we can know f equals to 1 over 6, right? And then, because f is equals to k over n here, so we know that k is 1 and n is 6, right? Make sure that you simplify the f into until the denominator and the numerator are prime number, okay? So, for example, if you have 30 over 60, you should first simplify it to 1 over 2, and then you say n equals to 2, all right? So for the first components, the n1 equals to 6. But don't forget that we have another component. Now the omega equals to half of the pi. And then we can know the 2 equals to 1 over 4 equals to k over n2. Okay, they're all prime number, so n2 equals to 4. Does it make sense to you all? You can see first component's period is 6, the second component period is 4, and we want to know the period of the whole x of n, right? So we need to find the least common multiple of 6 and 4. So the least common multiple of 6 and 4 is 12. And this is our final answer to the period. End of this question. How do you feel?
Quick question.
Sure.
I remember, I think something similar occurs in the continuous time case where you try and find the least common multiple, but you're not guaranteed that's the minimum period. Are you guaranteed that 12 is the minimum period for this discrete time, or could there be a smaller period?
I see. Thank you for your question. So the minimum requirement is satisfied when we simplify the k over n to the prime number form, to the simplest form. So in this case, if we don't simplify it to 1/2, we just say n equals to 60, then 60 is not the smallest. But when we minimize it to both of them are prime number, for example, 1/2, and then we say n equals 2, then n is the smallest number. It will make much more sense if we derive from the equation 2 pi fn equals to 2k pi, and we did not remove the 2 pi here. We will have fn equals to k, right? And let's say k can be any integer, right? We want to find the simplest version of the fraction. Let's say, for example, f equals to 5/6 in this case, in this example. If we do so, we want to find a pair of n and k that satisfies this condition, right? And let's say, at first we don't want. At first we want to make k equals to 1. We'll see that we cannot find any n that satisfy that, right? And then we make k equals to 2. We still cannot do that until we made k equals to 5, and then we can find a number n equal to 6, and this is a smallest period we can find in this case. If you continuously increase k to, for example, 10, you find a corresponding n equals to 12, right? It still makes sense, but n is no longer the smallest period. So by
I see it. So-
simplifying, yeah.
Oh, yeah. Yeah, this makes a lot of sense.
Yeah, good question. This also bothers me for some time. Let's remove these nodes to avoid confusion for the people who only read notes. Okay. I will continue to question 2. If you are still confused about question 1, feel free to unmute yourself or send me the question 2. All right, I should hurry up. Question 2 is unrelated to the question 1. So let's say we have a sequence 2, 2, 2, 1, 0, blah, 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 blah. And this is when n equals to 0. I want you guys to write it in terms of the impulse function. How should we do that? Anyone volunteer?
So wouldn't we have
Mhm.
so Dirac of n multiply that by 2 in the middle, like in for the equation,
Mhm.
and anything before that would be added. So let me see if I can remember what I did. Yeah, so
Mhm.
zeros, you don't do anything to them because they're already 0. But then so it'd be 2 Dirac n plus 2 Dirac n minus 1 plus 2 Dirac n minus 2 plus Dirac n minus 3.
Great. Awesome. Completely correct. Thank you. Thank you. And yes. So his answer is into several Dirac, and we can write it in terms of the Dirac, right? And then our next question is to try to write it in terms of Dirac as well as the unit step. I guess some of you have answer in your heart.
I guess for that also, it would be 2 times unit step of n minus 1 times unit step of n minus 2 minus 3. And then again, minus unit step of n minus whatever the next one is 4. I think.
Yeah. Thank you for answer. So the key here is to link the Dirac with the unit step. So it makes much more sense if we draw it. Right? And then you substitute this into your original equation. Or if you're familiar with it, you can directly write down that, oh, I saw 3, 1 here. So it should be u of n minus un minus 3. And then plus the fourth signal here. All right. Does it make sense to you? I hope it is. Okay. Someone asked, why our direct not have amplitude? Okay, so the direct have infinite amplitude in continuous time domain, but for discrete time, it is just 1 at n equals to 0. Okay. Thank you, Jerry, for your feedback. So let's continue to the question 3. Yeah, question 3 should be quick. Let's say currently I know that the xn is periodic. And then I invite you to answer, what about the even component of x, and what about the odd component of x? Are they periodic too? And in the lecture, we said that any discrete time domain signal can be, discrete signal can be expressed into the sum of E and N, E and O. Are they periodic? Do you think? What do you think?
Maybe it's not correct, but since you find, I think, x even by calculating like 1/2 of x n plus x negative n, I think, and then odd is like 1/2 of x n minus x negative n. Since you're like adding 2 periodic signals together that are discrete, but they have like the same omega, then like, hold on, let me think. Well, I guess never mind. One's negative omega. Never mind. I had to think on this.
What is your short answer?
Okay, I think yes, but I'm not sure.
You're right. You're right. Both your answer and your thinking process are correct. So if we go back to the definition of E and O, not definition, I mean the calculation, you can see that it can be right in terms of xn and x minus n. The same for xo. Because xn is periodic, x minus n is periodic. So the linear combination of them, the xe, xo, should also be periodic. So the answer is yes. And then I will check your understanding about another concept, the energy signal. Given that xn is an energy signal, what about x2n? Is it energy signal too? Energy signal means the energy of it is finite, smaller than infinity.
I think yes, sorry, because it should still, what's the word? It's
Yeah, I got your point.
converge, that's right.
Yeah, exactly. Your answer is correct. You can think in this way that we can split in the energy sum into 2 parts. The first part is for the n equals to, the k equals to 2n, and n can be any integer. And the second half can be, let's not use k before you get familiar with the notation. M equals to a plus 1, and right? The energy can be split into the 2n and 2n plus 1. We know that xn is an energy signal, and then the x2n means that we only want this part. So they're both positive, and you know the whole is small, so it's finite. So a subpart of it must be finite too. I hope it makes sense. All right, let's come to our
Sorry,
Go
back to your first point for number 3. Can you explain again real quick how you know it's periodic? Yeah, the first part.
Oh, sure. So, the assumption is that any discrete time signal can be split into even and odd part. And then if we write down, if we write minus n, we will also get similar result. Due to the properties of xe and xo, we know that xe equals to xe minus n equals to xe n, and this is equal to this, right? And then
Yeah.
just like the how we solve the multivariable equations, we want to derive xe, we can plus xn and x of minus n, right? The xo will cancel out, and then we'll get xen. And similarly, we subtract the x of minus n from xn, we will get, we can write down xo in terms of xn and x minus n too. So that is what I mean by these two expressions. And because xn is periodic, x of minus n should also be periodic, right? And the sum of them is also periodic. And we divide it by 2, it is still periodic. Does it make sense?
I see. Yeah. Thank you.
Good, good. It's always good to ask and pause because it's a way how we learn things. Okay, so let's come to the last question. Question 4. This is a bit difficult, but I'm confident that you can handle it. Let's say we have a time invariant system. You shift in input, the output will shift by the same amount. So let's say we don't know the inside of the system. We don't know the expression of the system, but we can give it some input and observe the output. Let's say that we give it an input of this 0, 1, 0. This is a starting point. And then it will transform it into an output 0, 0, 1, 0, for example. And then we give it another input, x2 of n equals to 0, 0, 2. And then let's say the system gives you another output, 0, 4, 2. And we don't know that if the system is relaxed or not. And we only know that it is time invariant. So now I want to ask you, is the system linear? Given the two trials, you can think about how we can utilize the properties of time invariance.
Wait, what do the arrows mean again? Like
arrow?
the one pointing up at the numbers?
Oh, arrow. Okay, so that means n equals to 0 here.
Oh, I see. Okay.
Yeah, it's just a convention. This question is difficult, so feel free to throw out any guess.
Maybe we can try to express x2 in terms of x1.
Yeah, a good thinking. Thank you, Alexandra. Yes. So, yeah, we can try if the linear assumption makes sense, right? If the linear assumption does not make sense, we'll say, sorry, it's not linear. Yes. So how to represent x2 in terms of x1? Remember, we say that it is time invariant. So the shifting will not change the values of result. It will only make the result shift too. So let's imagine that x2 also start from here. Imagine you start from here. And for the y2, it will also shift, right? It will also shift. Due to what? I know you have answered. Due to the time invariance property. All right, so let's observe. For the x1, it is 0, 1, 0. For the x2, it's 0, 2, something. So we can see that the x2, the new x2, it is basically 2x1n, right? Let's give you a new name. x3 of n equals to 0, 2, 0. And the y3n equals to And then we see x3n is 2 times x1. Does it make sense up to now?
Wait, I'm sorry. Can you explain if you multiply x1 by 2?
Mhm.
Don't you just get? Oh, you're just defining a new input x3 of n. You're not expressing anything in terms of it.
Yes. Yes and no. So I'm writing down x3 of n as a new input and xy of n as a new output, but it is derived based on the time invariance property. So the time invariance property means that when I shift an input, the output will shift too. So based on the x2 of n and y2 of n, we know that if we start at the new point here instead of the original one, it means that we shift it to the right. We add a delay. Not a delay. So we shift it by 1 unit, right? By 1 index, right? The output will also shift by 1 index. That's how I write down the x3 of n. We can see that.
Oh, okay, I see. Thank you.
Yeah. So probably I should write it in this way. I think this will make much more sense. Thank you for your question. Yeah, you helped me improve my notation. Yeah, so now x3 of n is 2 times x1 of n. If it is linear, the y3 of n should be equals to 2 times y1 of n, right? And let's see what is 2 times y, what is on the right-hand side. So it should be 0, 0, 2, 0. And on the left side, it is something different. Right. Yeah, Jerry gave me an answer. So they are not equal, which contradicts with our assumption. So we can say that, oh, it is nonlinear. So that is the end of the questions 4. Any problems? Any clarification questions?